there's a river of gas flowing toward the black hole at the center of our galaxy, 200 light-years long, carrying enough material to birth thousands of stars. And until recently, astronomers had no idea it existed. The center of the Milky Way is one of the most challenging places in the galaxy to observe. 26,000 light-years away, hidden behind dense clouds of gas and dust, lies Sagittarius A, the supermassive black hole at our galaxy's core. For decades, astronomers have worked to pierce through these obscuring layers, using radio waves and infrared light to reveal what optical telescopes cannot see. The galactic center isn't just home to a black hole. It's a region of extreme physics, intense radiation, powerful magnetic fields, and stellar winds from massive stars. However, a persistent question remains. How does this material actually get there? The Milky Way is shaped like a flat disk with spiral arms, yet somehow gas and dust manage to spiral inward, feeding the galactic center. That changed with observations from the Green Bank telescope in West Virginia. By tuning into specific wavelengths emitted by ammonia and other molecular traces, astronomers can map dense gas that remains invisible in different observations. What they found was startling. A giant molecular cloud that no one knew existed, roughly 200 light-years long, filled with dense material, and located along what astronomers call a dust lane, one of the hidden rivers carrying matter toward the galactic center. The cloud, now nicknamed Midpoint, sits in a transitional zone. It's no longer part of the galaxy's quiet disk, but it hasn't yet entered the violent environment of the core. But here's what makes this discovery particularly striking. Midpoint isn't just drifting through space. It's giving birth to new stars while being torn apart by radiation from older ones. It's a cosmic battleground where creation and destruction are happening simultaneously. The structure is classified as a giant molecular cloud, one of the largest concentrations of gas and dust in galaxies. At roughly 60 parsecs in length, Midpoint contains enough gas to produce thousands of suns. What makes Midpoint significant is its location along an inward-bound dust lane, essentially a corridor where material from the outer galaxy flows toward the center. Astronomers have theorized about these lanes for years, but identifying individual clouds within them has been difficult. The cloud was detected through radio observations measuring molecular emissions. Ammonia molecules emit radio waves at specific frequencies, allowing astronomers to determine where the gas is, how dense it is, and how fast it's moving. The data revealed internal structure, compact clumps of denser material, regions where gas is being compressed, and areas showing interaction with radiation from nearby stars. One clump, designated Knot E, appears to be a small, dense pocket of gas being eroded by starlight, known as a free-floating evaporating gas globule. The Green Bank telescope observes radio wavelengths, allowing it to see through the dust obscuring the galactic center and detect molecular signatures of cold, dense gas. The team focused on molecules that trace high-density environments, ammonia and cyanobutadiene. Previous surveys had swept across this region, but not with the sensitivity needed to resolve Midpoint. The cloud exists in what was thought to be a relatively sparse area. The breakthrough came from improved detector sensitivity, combined with targeted observations of specific molecular lines. Astronomers interpret Midpoint as part of the Milky Way's internal plumbing. The galaxy has a bar-shaped structure at its core that creates gravitational forces, funneling material inward along specific paths. Midpoint appears to be riding one of these inward flows. The observations show highly turbulent gas, suggesting chaotic motion rather than smooth flow. There's also evidence that stars are forming within the cloud. The discovery of a maser, a natural laser-like emission from excited molecules, often indicates active star formation. One intriguing feature is a shell-like structure within the cloud, possibly the remnant of a stellar explosion or an expanding bubble created by stellar winds. The discovery of Midpoint changes how we understand material transport in galaxies. For years, the flow of gas from the outer disk to the galactic center has been more theoretical than observational. Midpoint provides a direct look at this process, showing that dust lanes are real structures containing massive amounts of gas. And this raises a fascinating possibility. If there's one massive cloud flowing along this hidden pathway, how many others are out there? The Milky Way might have an entire network of these cosmic rivers, all feeding material toward the center, all invisible, until now. This has implications for galactic evolution. Central black holes grow by accreting material, and star formation in galactic centers occurs in bursts when sufficient gas accumulates. Both processes depend on a steady supply from the outer galaxy. Midpoint represents a snapshot of that supply chain in action. The discovery also raises questions about star formation in these transitional environments. Galactic bars are known to suppress star formation due to strong gravitational forces, yet midpoint shows active stellar birth. The leading edge of the bar where midpoint is located may be a special zone where conditions favor gas collapse, despite the turbulent environment. Questions remain about the cloud's ultimate fate. Will it survive its journey to the galactic center, or will it be torn apart by turbulence before it arrives? How much of its mass will form stars versus adding to the gas reservoir near Sagittarius A? The turbulent motion within the cloud is particularly puzzling. Is this turbulence generated by the cloud's motion, or is it being stirred by collisions with other clouds? Understanding these flows matters for more than academic curiosity. Every atom in your body was once part of a cloud like this. The Sun, the Earth, and everything in our solar system formed from material that flowed through the galaxy's disk billions of years ago. Midpoint is showing us how that process works. Future observations could test whether star formation patterns in midpoint hold in other clouds along the dust lanes, revealing whether this is a common stage in galactic evolution. Midpoint is likely not unique. Systemic surveys using the methods that revealed this cloud could uncover an entire network of these structures, providing a comprehensive picture of how the Milky Way channels material toward its core. This work demonstrates the value of molecular line observations. While images show overall galactic structure, molecular maps reveal the hidden flows that drive evolution. As radio telescopes become more sensitive, we'll map these features in other galaxies, comparing the Milky Way's dynamics to its neighbors. Future telescopes will observe midpoint in even greater detail, measuring velocities of individual clumps, tracking changes over time, and detecting fainter molecular species. Each dataset will refine our understanding of how gas behaves in extreme environments. The discovery of midpoint reminds us that the Milky Way still holds surprises. This cloud isn't a sudden appearance. It's been there all along, invisible until now. What we're witnessing is the gradual unveiling of our galaxy's hidden architecture. Midpoint is one thread in a larger story about how spiral galaxies build their centers, how they sustain star formation across billions of years, and how matter moves through gravitational landscapes we're only beginning to map. As observations continue, more of these hidden rivers will come into focus. The center of our galaxy remains active, structured, and full of revelations, and the next discovery could come at any moment. Another massive structure appearing in data, another piece of cosmic machinery revealed. If you want to follow along as these discoveries unfold, subscribe and turn on notifications. Astronomy moves fast these days, and the Milky Way isn't done revealing its secrets. There's always more to find when you know where to look.